think I'm.
I would think 50.
On my personal account.
Jake Paul. Okay, I have to turn it back on in a second. Okay, here we go. 4 times sine of x squared minus 3 equals 0. You wrote what?
Before. 4 times sine squared.
But sine squared is kind of weird because you want to do sine of the angle. So your angle is what? Well, yeah, you're right. Kyle said 120, but 2/3 pi is what I'm going to put in. And Kyle says it's 220. But that little squared goes on the outside like this. First you get the answer, the ratio. Once you get the ratio, you square it, take it times 4, and then subtract 3. Now, is everybody okay with 120? This is really what? 60 times 2, 120. So you're about there. Okay? If that's 120, what's the reference? 60, right? So this is square root of 3. This is 1 negative. This is 2. Okay, so what is sine of 2/3 pi? Square root of 3 over 2. Okay? But it's not sine of x, it's sine of x squared. So don't forget to square. Is this all going to get you 0? How do you square that?
You square both of the ones inside.
Okay, square the numerator, square the denominator. Numerator squared is what? 3. Denominator.
4.
Times 4 minus 3. Okay, multiply. Cancel out the 4s. 3 minus 3. Bingo. We got it. It's 0. So is it a solution? Yes. And you know, this slide is just saying this. Today you're going to solve equations. You're going to get a bunch of answers. And if you want to know if your answer's right, can you check your answer? Yeah, we just did. 0 equals 0. We got it. Okay. Awesome. Next slide. All right, this one. These unit circles were just put on so you don't have them, but if you want to put it on, go ahead. Solve the equation right here. There are infinitely many solutions, and we'll talk about that in a second, but let's just get one answer. You actually did this in chapter 4. How do we do it? Sine of what angle, that you're solving for x, sine of what angle equals that ratio? Louder,
Negative 45 degrees.
Inverse sine. Yeah, you guys, I'm not going to write this every time, but
yeah.
this is what you guys did back then. You just knocked out the sine. Inverse sine knocks it out. But then you got to take inverse sine of what? This. And believe it or not, guys, this was what messed you up in chapter 4, doing inverse trig functions. Now, what I'm asking you is, what triangle will give us this ratio? Yeah, it's got to be the 45. It's got the square root of 2 in it. Now, the ratio, though, is negative. And Kyle, you said 45. And 45 is going to give you square root of 2 over 2, because opposite 1 over this is square root of 2 over 2. Problem is, it's negative.
Maybe it's a
So where is sine negative?
second.
Quadrant what? 4, okay. For sure 4. Okay, and where else?
3.
And 3, okay. So basically, guys, this would be your answer, correct? Okay. So your answer is basically this angle and what? That angle. So tell me those angles in radians. This is 1/4
15
pi.
4.
Say that again, Noah.
7 pi over 4.
Okay, that one. Okay, he says 7 pi over 4 is the answer. Would you guys agree?
Yes.
Yeah, because a complete circle would be 8 over 4 to pi. Well, he's 1 short, so he said 7 pi over 4. This would be what?
5.
5 pi over what? 4. So there are 2 answers, correct? Or are there infinitely many? Yeah. So where are the other answers?
In the same spot.
In the same spot, if you just do
run around the circle.
yeah, if I went like this, guys, here's the answer. Right there, 5, 4 spot. But could I keep going? Here it is again. Here it is again, right? I can just keep going and going. So it repeats itself every what? Every 2 pi. If I make a complete circle, I get right back in the same spot. So I can say the answer is pi over 4 plus what? 2 pi. Because that would get me to the next spot. Same spot, I'm sorry. But if I did it again, same spot, same spot, same spot. So what I'm going to do is I'm going to put this variable n back there. And what that n stands for is integer. So you want to say n equals an integer. Okay, so an integer is 1, 2, 3, 4, 5, 6, 7, and on. Also 0, -1, -2. If you put 1 there, guys, I'm just saying make 1 circle. Put a 2 there, I'm saying make 2 circles. So it covers that answer every time. But wait, there's another answer. It's what? 7/4 pi. But if I keep making a circle, I'm right back on top of it, and then tell me how many circles to make. Just call it in for integers, yeah.
The first green equation, yeah. So why is it pi?
Oh,
over
you know
4?
what? I see what you're saying.
5 pi.
Yeah, that's 5. Gotcha. I knew you were gonna pick on me. He got it though. Okay. All right. Questions? Nope. Yeah.
When you said it's sign, like the inverse sign, is it restricted into 1 and 4?
You know what? I understand what you're saying, but we restricted it because we weren't using our calculators. So we were just saying, let's just give one answer. Okay. Here, when they just tell you solve this equation, you're supposed to think. What happened there? You're just supposed to think. He's just talking about any angle, and when you're talking about any angle, there's what? Implement. Okay. So here's the deal. Your eyes. Okay, there. Here's the deal. If you don't understand why this is happening, look at the sine curve. This is the sine curve you did in chapter 4. Here it goes up, down, and then back up at 2 pi. At 2 pi, we just do another one. At 4 pi, we do another one. But you know how this ratio was negative square root of 2 over 2? Well, look. Here's -1. Here's negative square root of 2 over 2. And if I come across, I hit it right there. That answer is 5/4 pi. Keep going. You hit it again right here. The answer is what? 7/4 pi. And see, if this curve just kept going, you'd hit it again here and here, here and here, over and over. That's why we keep putting the what? Plus 2 pi in. You make a circle, you're right back on. Yeah? Okay. Next. Let's try this one. Did I go, and is this going in order? Yes. Okay. What do you notice that's different?
Signs on both sides.
Signs on both sides. Okay. Hey, in your mind, just go back to algebra 1 and algebra 2. This is like saying sine of x. It's just like saying x minus a number. I'll just say square root of 2 equals -x. How did you solve that in algebra 2 or 1?
Set it equal to 0.
Okay, so
Add it.
I was thinking, yeah, you'd say just move the x over, add x, right? And add x. You'd end up with what? 2x minus square root of 2 equals 0. And you'd start from there, wouldn't you? Okay, well, it's the same thing. Get your signs on one side and your numbers on the other. That's kind of how you do it. First step is what? Add sign. Okay, let's add sign. So we're saying negative sign plus sign out. That makes 0. Plus sign over here. Sine of x plus sine of x is what? 2 sine of x minus square root of 2. Now remember, this is kind of the look you want, right? Paul, here's this. Sit still. Okay, this is the look you want. Just sorry. What are you gonna do? Yeah, and then you just add the square root of 2 over here. Okay? Sine of x equals what? Square root of 2 divided by 2, right? Okay, well, it almost looks the same as the other one I did with you. I did this one. Negative square root of 2. Now I've got what? Positive square root 2 over 2. So you probably know to get x, you'd have to do one of these. Inverse sine of square root 2 over 2. What triangle is going to do it for you? 45 again. But now the ratio is positive, so where is sine positive? 1 and 2. Go back up. This might help you just to put it in there. 1 and 2. And then you can kind of look at it and say, yeah, this would give me square root of 2 over 2. So this is 1, this is negative 1, this is 2 square root of 2. And you can see that this over that is square root of 2 over 2. 1 over this is square root of 2 over 2. So the answers are, here we go. What's this answer?
Pi over 4.
Pi over 4. What's that answer?
Pi over 4.
3/4 pi. Right? Okay, so I'll come down and I'll just write those again. So you said x can be pi over 4. But remember, if you make another circle, you're right back on it again. So plus what?
2 pi.
2 pi.
2 pi n being what? How about any integer you want? So if I said 5, n is 5, that just means take that angle, make 5 circles. Are you right back on it?
Yes.
Yeah, I mean, that's all it means. Okay, the other one was x equals what?
3 pi over
3/4 pi plus
2 pi over
2 pi n. Okay. You just have to know what quadrants your answers fall in. Because I had a positive ratio and it's sine, it's in quadrant 1, quadrant 2. The previous problem was negative, quadrant 3, quadrant 4 for sine. Okay? I should have asked some questions. Are you okay? All right, now we're doing it again, but now we're doing it with what function? Cosine. It would be really nice if it was just cosine of x, but it's not. It's cosine of x squared, or cosine squared. Okay, so that's like saying this. Go back to your early days in algebra. That's like saying, I don't know why I put a 2 there. I meant a 4. Okay. That's what you did this for cosine squared minus 3. How would you do this? This problem.
Add 3.
Add 3.
Divide by 4.
No, you guys got it. Go ahead, do it. Do this one. Get that far? Now what? Yeah, you wanted to say cosine of x. So let's get rid of this square. Okay, so cosine of x should equal that, but that is the same as this. Right? Just break it into 2 pieces, numerator, denominator. Answer on top. Over. Answer on the bottom. 2. Good. Something's missing. Well, okay. Yeah, I suppose I could do that. X
Plus
equals
2
inverse
pi.
cosine. But something's missing.
No.
You took the square root of both sides, right?
Oh, plus or minus.
Plus or minus, yeah. So now you're saying the ratio could be this, or it could be this, negative. So now I'm asking you this. What angle, if I took the cosine of that angle, I'd get this ratio. Square root of 3 over 2. Well, it's got to be either a 30 or a 60, right? You think it's a what? Okay, Will's saying 30. Let me just check it out, Will.
I'll say 60.
Okay, let's do 30. 1, 2, square root of 3, do cosine. Cosine is what? Square root of 3 over 2, that's what I wanted, yes. But now looking at that positive ratio, cosine is positive in what two quadrants? 1 and 4. So this same triangle is just down here. Still a 30, so it's -1, it's still going to be square root of 3, and it's still going to be 2 here. So wouldn't this take care of the positive ratio? How about the negative ratio? Where's that?
2 and 3.
Yeah, it's just over here. It's still going to be your 30. That's the nice thing. Nothing ever, the reference angles don't change. And this one, I'm not going to put the numbers in, but it does work. I suppose it should. Negative square root of 3 over 2 and over 2. So it does work. Here comes the question. The question is, what angle is going to work here? Well, it's this one. What's that angle? Pi over 6. Okay, keep going. What's this one? 5 pi over 6. Keep going. This one.
7, 6.
7, 6 pi. Keep going.
11, 6.
Yeah, that's 11 6 pi, right? 11 6 pi. Okay. So now, how many answers? 4 answers because you had 2 ratios that could have worked. Positive square root of 3 over 2. Negative square root of 3 over 2. Cosine's positive in 2 quadrants. And negative in 2. That's why there's 4. Okay, but when you write your answer, guys, watch this. First answer is what? Pi over 6 plus, what are you going to put? Okay, you're going to put plus 2 pi n, says Grace. Okay? Grace says 2 pi n. I agree with you. And she can do that every single time. 5 6 pi plus 2 pi n. 7 6 pi plus 2 pi n. 11 6 pi plus 2 pi n. But wait a minute. Watch this. That's your answer? Well, guess what? What if you just went pi? Would you land on another answer? Uh-huh. So you could just say pi over 6 plus what? Pi n. Because if you go half a circle, you get to another answer. See, in the back of the book, this is what they're going to do. And you're going to write all 4 of them. And you're going to go, why did they do that? Because they're saying half a circle gets another answer. Just like this one. This could be an answer. 5 6 pi, right? Okay. But if you do half a circle, you're at the other answer. That's what?
11.
Well, no. But you could take care of it just by saying plus pi n. Okay? So do you get why I said pi n, not 2 pi n?
Yeah, but which ones should
Okay,
we
so Will, I can say this, and you can do this on your test. You can do this. This is my answer, so is this. So is this, okay? You can do that 4 times. This, say it 4 times. But I'm taking care of that by saying it much quicker. I'm saying pi over 6 is an answer, right? But if I say plus pi, where am I at? Right there, 7 6 pi. So it works. I don't have to say it 4 times. I can say it 2 times. And this is just when I say n is what? An integer. And so if I say pi times 1 right here, pi times 1, that's 1 half circle. 2 would be a half and a half. It would be a full circle. I'd be right back on this spot. Yeah? Okay, keep going.
Peter, which one should you use though? Like, which radian measure should you use when you're doing the
you're-
plus pi? Because like, if they only have 2 answers in the back of the book,
I would just go in order. I'd say, well, there's my first one.
okay,
That takes care of my second. That's my second one. That takes care of my.
okay,
But if you said this, 7 6 pi plus pi, oh, that's the answer. Plus pi. It doesn't matter, Molly, but
okay,
I start from 0 and just say, first one's this, second one's this,
okay.
and then by saying pi n, you've taken care of all of them. Okay, here we go. Use the factoring techniques and identities from previous work, and the zero product property. Okay, which basically said that a times b equals 0 if what? That's only true if a is what? Or what? or b is 0. So that's something you guys used many, many times in Algebra 1, 2. So they want you to use some factoring techniques. That's tangent squared, that's just simply tangent, right? That'd be like this. Tangent squared would be like x squared, and then 2 tangent would be just like 2x. And they want you to factor this. What would you do?
Say equals 0.
You said move it to the left? Okay, how? Yeah, subtract 2x, you get this, wouldn't you? And how do you factor that? You just what?
Take out
Take out the GCF, exactly. I'm not going to continue this, just start it with this. Do exactly how, what Grace said to do. Move your 2x over, but you're not going to do that. You're going to move your 2 tangent of x over. Okay, moved it over. Now what? Take out the GCF. They share tangent. Take out tangent. Once you do that, what's left?
tangent minus 2.
Tangent minus 2. Gotcha. Tangent of x minus 2. All right. Now, tangent of x times tangent of x. Sorry, tangent of x minus 2. So when is this number times this number going to be 0? Yeah, either when the first one's 0 or when the second one is 0. So we got to solve it. When is tangent of x equal to 0 over 1? Well, that would be inverse tangent of what? 0 over 1. What triangle has opposite over adjacent? 0 over 1. None. There are no triangles that works with. So we got to go with what? The unit circle right here, or here, or here, or there. On the unit circle, the radius is 1. This point is 1, 0. 0, 1. Right? And 0, negative 1. Okay? Tell me tangent. I know it's opposite over adjacent, but tell me x, y's, and r's. Y over x. Where do you see y over x? Y is 0, x is 1. 0. Here. Y is 0, x is 1. It's right here. So the first answer to this is when x is what? 0. Right there. That's the first answer. Where else do you see y 0, x, x 1, I guess? You kind of see it there, that's negative 1, but you know what, guys? This is what? This whole number is what? 0. So when are you going to get 0? Is 0 divided by negative 1, 0? Yeah, so this also works, right? So you'd have to say this answer comma what? Pi. Okay, so really this works, right? That's an answer. Okay.
2 pi work as well.
What's that?
The 2 pi work.
And what? Yeah, that was going to ask you. Then if you made a complete circle, you get 0 again. A complete circle, you make the pi again. But hang on. Does tangent have a period of pi? 2 pi? Do you guys remember the graph of tangent? Here's the graph of tangent right here. The graph of tangent went from negative 90 to positive 90. So the period was what? Just pi. So when you get an answer for tangent, it will repeat itself pi radians later. I tried to show you this one where tangent of x is 1. What angle will give me inverse tangent of 1 over 1? Well, it turns out to be 45. And if I go across, I hit it here, there's a 45. But if I keep going across, I hit it here again. The distance from here to here is pi. So they repeat every pi, not every 2 pi, every pi. And you can see that. Look, here's your first answer. Where's your second one? Pi over, right? So you could just say what? You could say 0 plus pi n. Yeah? But hang on, there's another one. It's right here. Come on over here. And here's the problem with this one. If you set this equal to 0, tangent of x minus 2, well, that will be 2, I guess. How are you going to do this? How do you do inverse tangent of 2 over 1? What triangle gives you opposite 2, adjacent 1, 30, 60, 90?
Doesn't have to
So
be
you-
1 over
You want a 30 or a 60?
No.
Okay, if I did that, Molly, if I just put a 30 here, I get a 1. There's a 1. But this side's square root of 3. I don't think it's working. Okay, it's not working. So now what? Don't have any triangles, guys, that work. It comes down to your calculator. Your calculator is going to tell you the answer to this one. This will happen in your assignment. You'll get these funny ones that you just don't know. Use your calculator. So inverse tangent of 2 over 1 is what? I need some help. Don't make me do this. 63 degrees. Can you give me a little more than that? Like 0.4. Okay. So there's the answer right there at 63. So let me just draw that for you. Here's the answer, 63.4 degrees. Okay, but wait a second. Hang on. Tangent is positive in quadrant 1. Tangent's also positive in quadrant 3. This angle is this triangle is identical down here. Same triangle. So this reference angle are the same. This ends up being the other answer. But doesn't that look like how far around the circle? Yeah. One period later, you get another answer that works. So the answer here would be 63.4 plus, don't say pi n, because pi is radians. Now you'd have to say what? 180 n, right? Okay. But the back of your book is not going to say this answer. Your back of your book's going to stay in radians. So can you do this again for me? Don't tell me 63.4. Go in radians. What's the answer in radians? I think we already know it's that. In radians, what's inverse tangent of 2 over 1? Right here. What is it? 1, 1. Okay. Okay, that's what's in the back of your book. Even though that is the same thing. Okay? All right? This is what you're going to see in radians. Okay? Questions? Okay, last one on this page, I think. This one is kind of different because why? Two different functions, secant versus tangent. You know, when you guys solve equations, you like it just to be x's or y's, and let me solve for x and let me solve for y. Is there anything I can do here? Change it to what? Okay, so Maddie says this can be changed to what? Okay, and she's right. Using her identity, secant squared is this. She just replaces it with this, puts her 3 back out here, subtracts this, right? And this is squared minus 4 equals 0. Now let's clean it up a little bit. So what could you do?
Distribute.
Yeah, just start this. Yeah, run the multiplier through. This is 3. This is 3 tangent squared, followed by minus 2 tangent squared. Oops, I got x's and thetas. Minus 4 equals 0. Okay. Let me get theta here. Okay. So I multiplied. Anything else I can do? Combine like terms. 3 tangent squared, take away 2 tangent squared is? Tangent squared. 3 on the front, minus 4 in the back. Equals 0. Is this still the same slide that says use factoring up top? Can I factor this?
Yeah.
How?
Difference of 2 squares.
Difference of 2 perfect squares, yeah. This is a perfect square minus a perfect square. What is it?
Tangent of theta minus 1.
Okay, minus 1.
Tangent of theta plus 1.
Got it. That's it. All right, I got them factored. So when is this factor times this factor 0? Set them equal to 0. So if you set them equal to 0 and solve them, this would be when tangent of theta equals 1, or when inverse tangent equals 1 over 1. The other one, without showing all that work, guys, it's going to be tangent of theta equals negative 1. Inverse tangent, whoops, negative 1 over 1. Okay. And the question becomes, can you do that in your head? Or do you need your calculator? Is there a triangle that you go, y over x is 1 over 1? 45. And it happens, positive ratios for tangent happen where?
1 and 3.
1 and 3. Okay, so there. Okay. So the answer is to this one, 40 what? 45. But that's just pi over 4, right? Would you agree that there's another answer, right? How far away? Plus pi. And? Okay. Now that one, that's just negative, so that's the other 2 quadrants, correct? That'd be this quadrant, that'd be this quadrant. They're still 45s, aren't they? What's that answer? 3/4 pi. And where's the other answer? How far away? Pi. So you could just say, well, you could say 7/4 pi, but by me writing this, okay, if I make n 1, Will, 1 times pi is pi. Pi plus 3/4 pi would be right here. It is 7/4 pi, but I don't have to say it. I can just leave it like that. Okay? And again, on the test, would you please write this on your test quiz? What's n? Easy. Okay. Solving equations, you've been doing it for a while. The only thing is now you're doing the trick. All right, last one. Oftentimes we restrict the domain. This is kind of, Maddie, where you were going. Sometimes there's a restriction and you just have to listen to what the book's telling you, or the test or the quiz. Here it says solve for x is in the what? Interval 0 to 2 pi. So all you have to now think about is from here to here, where are your answers? That's it. Don't say plus 2 pi n. Don't say it, because you're just going 0 to 2 pi. I got a sign on the left, a cosine on the right. Is there a way I can make them both cosine or both sine? Is there an identity that can change the sine to a cosine?
Not in their current state.
Divide by sine.
Divide by sine. Then I'd make
Tangent.
that one 1 plus 1 over sine, then that would be cosine. Now it's hard, isn't it?
Couldn't you multiply by both sides by sine x minus 1 so that it turns
Sine x minus 1.
and you'll end up with
Yep.
sine on the other
Well, then you'll get sine x minus 1. This would be sine squared
that would be cosine.
minus 1.
Then you end up with sine on the other side.
Yeah, but then you're going to have sines and cosines on the right.
You divide by.
Here, I want to show you something. This is kind of cool. But if you do whatever you do to the right side, you have to do the left side. Watch this. What if I went that, square it, what do I get? Cosine times cosine is? Cosine squared. Can you change a cosine squared into a sine squared?
Yeah.
Yes, that's what you want to do. So when you get these tough ones, you just don't know what to do. If you just square both sides, things come out kind of nice. Now this one you have to FOIL. This one's not the greatest. You would get sine squared followed by
2 sine.
sine of x, 2 sine, you're right. And then you would get plus 1. Sine squared plus 2 sine plus what? 1 equals cosine squared. But you guys can replace cosine squared with, what is it?
1 minus sine.
Yes, 1 minus sine squared. There you go. Okay. Now, you've got sines all over the place. Let's get them all on one side. Let's see if we can factor it and solve it. All right, ready? Let's move this. I forgot my 1, didn't I? Right here, plus 1.
Yeah.
Okay, so if I go minus 1, minus 1, the 1s are all gone. If I get rid of this, it's add sine squared, right? Gone. Add sine squared. What do you get?
2 sine squared
2 sine squared
plus 2
plus 2 sine
0.
equals nothing. And that's what you want. You want it to equal nothing. Now, this has a quadratic look to me, guys. Quadratic looks you can either factor them.
out a 2.
What do you say?
Factor out a 2.
Factor out a 2.
So,
2's good.
Factor out of 2 sine.
2 sine's better. Okay. What's left? What's left?
Sine
Sine of x
plus 1.
plus 1. Yes. How many factors do you have? 2 factors. This times this. When is this going to be 0? When is this going to be 0? Okay. This will be basically when -1, inverse sine of -1. Right? This one will be divided by 2. 0. So x will be inverse sine of what? 0. All right, now your job is to think back to your triangles. We're doing sine. Where do you find a triangle that has 0? Opposite side 0? 30, 60, 45, are any of the opposite side 0?
No.
No. This is y over what? R. You can't find a y value 0 on those triangles, so you got to go to your unit what?
Circle.
Okay, so here it is, here it is. And just look at these ordered pairs. 1, 0, 0, 1. And 0, -1. Okay, so now your job is, ask yourself, where do I see y 0? Yeah, right here. And right here. And if I took 0 over the radius 1, wouldn't I get 0? 0 over 1, 0. 0 over 1, 0. So the answer is what? 0 radians and pi radians. Okay. I knew you were going to say that, but here's the deal. They did restrict you guys to what? They restricted you guys to And this one just basically 0 to 2 pi. See, from 0 to 2 pi, you can give me all your answers. 0, 2 pi, oh, sorry, it was 0 what? Pi. But then there's another one. It would be what?
2 pi.
This one's what? 2 pi? This is y. This is r. Where's y? Negative 1. Right here. Here's y. Negative 1 over the radius 1. You guys agree with 3 pi over 2? Okay, this one's 3 pi over 2. Oh, no. 3 pi over 2. Okay? So between 0 and 2 pi, there are 3 answers. Or are there?
Wouldn't there be 4 because 2 pi is included? So
Hang on. Let me go back up. Let's look.
because it's 0 to 2 pi.
Right, I know. I'm going to look. Oh, okay. It's 0 with the bracket. That means 0 is included. 2 pi with parentheses. We don't include 2 pi. So if 2 pi is your answer, we don't want it because it's not included in this interval. So, okay. Now, hang on. Here's the deal. One thing I didn't tell you. I did tell you back in chapter 2, if you square both sides of your equation, you sometimes bring in extra answers. They're known as extraneous answers, solutions. You need to do what? To see if they're right. Plug them in. You need to check all 3. One of them doesn't work. Okay? One of them doesn't. Let me just show you the one that doesn't work. Look at the graphs. When is cosine going to be what? Equal to sine of x plus 1. That's what we did. Well, if you graph cosine, guys, it's right here. It's the blue one. This is cosine. Okay? If you graph sine of x plus 1, that just means move sine of x up 1. Well, sine of x starts here, but move it up 1, it starts here. Okay? The answers are, when are they equal? Here and here. Now here's the problem. The x-axis is not in radians, it's just 1, 2, 3, 4. So if I did this correctly, this would be pi over 2. This would be pi. This would be 3 pi over 2. And this would be 2 pi. Okay? So where are the answers? Just look at the graphs. Look right here. 0 is an answer. And 3 pi over 2. What about, didn't we say pi was an answer?
We squared it.
Are they touching? Are they equal? No.
No.
Okay. So guys, if you went back and you did check those answers, they'd all work except which one? Pi would not work. So, there. That's a heavy hitter. That's a big hitter on a test. 6 points. 6 points. If you don't cross out that, you got 5 out of 6. Because you didn't check your answers. The only time you probably need to check your answers like that would be if you square both sides. Because you bring in extra answers. If you just keep your notes in front of you guys as you're working this out, you'll be fine. Because we did them all. Now, tomorrow will be much quicker because you know what you're doing, and there's just one little wrinkle tomorrow. Just one small thing. Okay? So I'm thinking tomorrow, 15 minutes talk, a good solid 30 minutes work. Okay? It's a day 1, it's a day 2 assignment, but get a lot of them done tonight. Check your answers as you go.
What do we do?
Fishbowl.
If you want to see a quick one, you can
Oh, yeah.
talk to Mr. Lazar, he's got them.
Did everybody get their speech?
So like on the board,
Yeah.
look at